Good morning, everybody, and welcome to this week's edition of the Field Crops Virtual Breakfast. My name is Jenna Thaler, and I'm an educator over in the Thumb region. We're going to get to the main feature here, or one of the two main features. We have Dr. Mike Reinke with us. He is a viticulture specialist and UAV operator with Michigan State Extension. Thank you so much for joining us, Mike. Are you ready to start sharing your screen?
I am. So I'll get started right away here. I'll start out by saying I apologize to all the field crop people out there. I am a grape specialist, so I work in fruit. So don't throw any virtual tomatoes at me. But I will say, from a UAV standpoint or an application drone standpoint, these are such general capability tools that once you get involved in one crop, you get involved in everything because they are so adaptable to so many situations. Uh, Arguably, I know that someone's going to come up with a disagreement, but arguably this is the first tool in the last 100 years that we can use the exact same tool to spray corn and soybean and wheat, but at the same time use in fruit crops, use in ornamentals, use in greenhouse coatings, weed management, forestry management, the exact same tool. Because of that, it presents its own unique set of challenges, but also a lot of potential opportunity. I'll get straight in here. I'm going to be talking today about some of the challenges primarily, but we'll start with a slide on benefits that some of you have heard about over the last few years. If I can get my slides to work, there we go. So, some of, when we think about it, especially in the agricultural system, you've probably heard presentations about application drones before. You've probably even seen demonstrations. And when we talk about a lot of the benefits uh, in the agriculture space, we talk about an application method. So, what does that give us? It gives us the ability to do spot applications. We only have to hit, we don't, if we have to, if you have a problem in a very small portion of your field, say you have a 100 acre of beans and a plot, and you only have a weed problem in about 5 acres, you can actually go out there with the drone and only treat those 5 acres, without having to traverse through the rest of the field. You have the ability now with some of the drones, they actually have it in their software to do variable rate application of various things, whether you're talking about variable application rate of cover crop seeding, or of pesticide where you're hitting your hard spots. You have that opportunity. But one of the other benefits is that it's in the air, so you don't have to worry about soil compaction. Or what if you have a wet ground? You don't have to worry about rutting the soil or ripping up the root systems of the plants that you're driving through. So you can go out there whenever the time is appropriate for that application, not waiting for the ground to dry. You don't have to worry about damaging the crop. You're always going to lose a proportion of that crop that is just getting driven on. Where drones, you don't have to worry about that. Drones also have the ability to do it's potentially a very quick application, as fast as a boom sprayer in a very large field or an aerial, or like a crop duster. Maybe not when you're talking about big fields, but when you're talking about small difficult fields, it can be pretty quick. Reduce risk to the operator. So you have these opportunities, but what are some of the challenges? When we talk about challenges, we're talking three specific things that really consistently become our challenges. One is, how do you become legal? How do you do this appropriately? And then the other one is knowledge. How do you know how to use these things correctly? I'm not going to go through the third one, that comfort with technology. We know how that goes when you're looking at new stuff. Some people are just more comfortable than others with trying something new. But the first two I'll go through here real quick, Jenna. I'm going to try to stay on track here. Um, so legal framework. Won't go through this all. If you want to look at it deeper, you can look at it in the recordings. But here in the US, we have a number of things we got to jump through, hoops we got to jump through to get legal here. The federal government, we have the FAA, which we have several exemptions or certifications depending on whether you're just flying it. Are you flying a big one? Are you dropping hazardous products? And then with MDARD, are you doing your applications privately on your own farm? Or are you doing this for hire? It changes the restrictions or the regulations you have to follow through. So this is a fairly straightforward one. Grab this slide later, but I'm going to go to some of the other benefits, or sorry, the other challenges. The biggest one is really understanding how to use the sprayer correctly. This is a sprayer. It's not a toy. It's not this new fangled thing that is that you can ignore the rules of physics about. It is a sprayer, so you have to know how to use it correctly. When you're thinking about spraying, you want to get the right droplets sprayed in the right way, going to the crop and connecting to the crop in the right way. And if you lose any of those variables, you're losing your success in your spray. So, what is that? What are the variables that you can think about from a drone? We've got several. Most people are thinking about how fast you go and what's your droplet size when you're talking about a ground sprayer. Well, here we have to worry about how fast are you flying? How high are you off the crop? How wide do you think that drone is spraying, versus how wide is it actually spraying? And you have the ability to adjust drop time, and then several others. So one slide on each, just to kind of give you a sense of what we're talking about. But before I do a lot of talk on spray liquids, but don't forget the same rules apply to granular products as well. So I tend to forget that. So I put this slide in here so I'd remind myself to let you know the same physics apply. These new drones have switched over from our traditional nozzles over the last couple of years to something called rotary atomizers. Uh, this allows for very quick adjustment and easy adjustment on the fly. So I bring this up specifically to say these things are getting more and more adaptable, and therefore our knowledge needed to use them correctly keeps getting increased year on year. You have to learn more things. So staying up to date with the technology is very important for knowing how to what the variables are in these drones so you can keep track of what you need to do it correctly. So when we talk, I'm going to go through these challenges here real quick. The first one, think about height. Think about speed. When you're talking about speed, when we think of productivity, we want to go fast. We want to get it done as quickly as possible because that's the cheapest way to do it or the most profitable way to do it. The problem is these are air assist sprayers just pointed down at your crop. And if you go really fast, you're not utilizing that air to your best abilities. So you want to slow if you can. It depends on what you're doing. If you want to just hit the tops of your crop and move on, say you're doing a systemic burn down of a herbicide, that's fine. Fly fast, large droplets, hit the top of the whatever that weed is, and it'll die. But what if you want to get down into the ears of a tasseling corn? You want to push into that canopy harder. You want to be able to get down in there, and you may have to slow down to open that canopy up to allow those droplets to get deep into that canopy. So understanding speed is really important for depending on what situation you're in. Height. Here's some research from some work that I did a couple years ago, looking at different heights, same speed, same coverage, same gallons, same droplet size, same speed, just changing the height. And this is the look of a swath. So imagine the drones coming in or coming out of the screen. And that's the profile of the swath. If you're at 15 feet above the canopy, you see where the gray is below 5%, the orange is 5% or higher, and then the blue is above 10% coverage on a card. So you can see same gallonage, you change your percent coverage as you get down closer to the crop. Part of that is spread. Some of it might be a little bit of drift, but a lot of it is probably evaporation of the droplets. It only takes a few feet for things to start evaporating on a dry, hot day. So understanding height is really important for whatever you're using. Swath width. This is the big critical one that seems to be killing a lot of new drone applicators. They think they can follow the manufacturer's recommendations and going really wide with their swath. Manufacturers say up to 36 feet. We're finding with these big drones, a lot of them are somewhere around 21 to 24 feet, maybe even a little less in some conditions. Maybe you're doing a herbicide application on an open field. Maybe you can go a little wider. It all depends. But you can see the yellow and green striping on this field from someone who just went a little too far on their swath recommendations or on their swath patterning. So you can get failure if you try to stretch it. Another one is looking at droplet size. This is on the left is percent coverage, on the right is droplet density, and the same setting is the same color on between the two. And this is basically just to say you have an inverse relationship between droplet density and percent coverage. So if you depending on droplet size. So if you want to go with a really fine droplet, say you're putting out a contact fungicide or a contact insecticide, you want really small droplets spread throughout that canopy so that there's a better chance of intercepting that disease or insect. But that means you have to change your droplet size, change your droplet density so you get lots of them, but it might reduce your percent coverage a little bit. That's a balance. But if you're doing a systemic herbicide or a systemic fungicide, go with those big droplets, reduce your drift, get your better percent coverage, but your droplet density drops dramatically. You got to understand this depending on the conditions. Spray volume. This is something that gets talked about a fair bit. You know, I can't get that much volume out of a drone. We're stuck with small volume. That's because you want to go really fast and you don't want to compromise productivity. I have personally sprayed 90 gallons to the acre out of drones. I know some people that have sprayed 200 gallons per acre out of drones. It's possible. You just have to slow it down. I consistently spray 10 to 20 gallons per acre in the fruit side. It all depends on what you're willing to go with. But you see here, as you reduce your gallonage, you get down to a threshold where you get below 5 gallons to the acre, and you start compromising your percent coverage, your ability, and it's going to narrow your swath down because you have fewer droplets out there. It's a game of physics. So make sure you're putting out the appropriate gallonage for what you need. Some of it's on the label. Definitely follow the label. Never go below. Sometimes you might want to go above the minimum on the label. The other one is adjuvants. Adjuvants affect your droplet size. They affect the density of that droplet. They affect the droplet's ability to evaporate. So what are you putting in the tank? That's going to change things. That's going to change how that droplet moves in the air. What's its drift potential? What's its ability to stick to the plant versus just bounce around between some leaves? Just make sure you know what you're doing if you're looking at your adjuvants. How is that going to impact all of the other factors we've just been talking about? And the last one is this is not so much a factor in a lot of field crops, but it can be depending on what you're growing. Do you have something that's grown in very distinct rows with space between the plants in the row, and maybe you've got a little bit of a canopy going on? We've seen in the fruit space, the vegetable space, ornamental space that row direction of flight can mean a lot. This is an example in my grapes where you fly with the row, the air. We've seen in research in other countries that the air kind of follows the row, and the droplets that are with that air tend to get stuck between the rows of crops, where if you fly against the rows, all of a sudden that air gets swirled up and gets caught in the canopy, and you get better coverage because the way the air interacts with the canopies. So I know it's not a major factor for this crowd in most cases, but what if you're trying something a little bit different? What if you're growing vegetables as well? It's good to have that in the back of your head. So that's all the benefits and challenges. Kept on time here. But I wanted to throw this out real quick. If you want to learn more, I did a fun video. I guess it's been about a year and a half ago with my colleague, Jason DeVoe. Over in Canada and Tom Wolfe. We made a fun video about it's educational. It's part of his series called Exploding Sprayer Myths. This was episode 14, where we actually did I think it's 7 minutes, so forgive me. You got to keep with it for a while, but it's a 7 minute video where we do a spoof on Top Gun. I'm Goose. I don't get killed, but I do get maimed by a sprayer. And forgive me ahead of time for the poor singing, but it's a fun video for you to watch, and it's educational as well. Collaborators, industry partners for the recording, and I assume no time for questions, but I'm here and can be in the chat behind the scenes.
And we'll come back to your questions, Mike, after we
Okay.
get done with the weather with Jeff.
Perfect. Cool.
We are now into the Q&A session of today. So make sure you are dropping any questions you have in the chat as we go. First up, let me get to the top of my screen so I don't miss anybody. First up is for Jeff. Do degree days need to be adjusted with solar radiation amount?
A good question, and the direct answer is no. And there's some context though that's important because it's a valid question, and the temperature and the solar radiation cycles, of course, are linked together. But for our crops, the reason we use those degree days is because the phenological growth and development rates of many crops, and particularly for corn, are highly dependent on environmental temperature. And so if we use the air temperature as a proxy for that, we can get really close to what the actual development rate is. So in this case, the answer, at least on the surface, no. But there are some crops where that would or potentially could matter. But here, I think we're really looking at these numbers, especially for corn. Soybeans, remember, are photosensitive, and so they have another mechanism in their genetics to help them along during the season. That in addition, they're also, of course, temperature sensitive as well, but they also look at day length changes. And so, but corn is just the ultimate example of a crop that's highly just dependent on that air temperature or the environmental temperature. So in this case, the solar, we would not have to make any kind of adjustments. We can go with just the air temperature.
Thank you. Now to you, Mike. I know you've been answering these in the chat, but we're going to go ahead and have you answer them live as well for those who can't see it.
Sure.
How do you know how wide to spread?
The easy answer is, well, it depends, and it takes experience. But what we can do is do some early testing when you first get the drone out on the field. You can, if you're doing a granular product, because the question said spread, I would think you want to put out some sort of collecting system, say pans or some sort of fabric or something that'll collect it instead of it bouncing. And you put them kind of near the edges of where you think your swath is, and you put a couple of them there, and you can see what you're catching out there on the end. You can use water sensitive cards if you're doing liquids, and kind of do the same thing. And you can get used to what you're doing. Now, don't do this out in the road when you're going to be spraying in your mature soybeans, right? Your flowering beans. So do it in the canopy or in the crop where you're going to be. Or the situation. But yeah, you can do that, and then you'll adjust your swath according to what you see on your spray cards or in your pans. But I did throw some numbers out there just to kind of get you started. If you're not sure, typically we're talking a little narrower for our granulars, so maybe 16, 18 feet and go from there. On liquids, probably start at 21 and kind of spread from there. Those are some conservative numbers to get you started.
And I know that I've seen when people are doing cover crop seed, they've put out like quadrant things just to see how even their spread even was.
Yes.
I don't know. Would that be
Oh,
helpful for granulars in this kind of case?
Absolutely. I mean, we're talking about how wide the swath is right now, so I was trying to shortcut it and make it
Oh,
easy
yep,
for the
that's fair.
edges. But I highly recommend putting spray cards throughout your swath if you're doing liquid, or you put pans throughout what your swath is, so you can not just see where you're hitting, but what's your pattern, what's your density, how even are you spreading, or how even are you spraying? I would highly recommend doing that every so often just to get comfortable with your sprayer, even if you feel like you're comfortable with your swath width, just to make sure. Because sometimes you see failures in your drone. Maybe you've got a motor that's a little slower on one side. It's not failed, so you can't see it with the eyeball, but you'll see it on the paper before it fails completely. So yes.
Very nice. So do the newer drones have GPS and programming capabilities for coverage patterning?
Yes, they not just GPS, but RTK, which is super high precision GPS. Standard GPS is basically 10-foot resolution. RTK can be down to 1 or 2 inches or less. So the drone always knows within X, Y, and Z, all three axes, it knows where it is on the planet within an inch or so at all times. And I don't usually fly my drone. I fly it very rarely manually. It's all autonomy. So I set up a pattern on the screen right before I fly. Usually it's a minute or two before I fly. I hit go. It goes and flies. It empties the tank, runs out of battery, comes back. I fill it when it gets on the ground. I don't even land it. And then I fill it, put new batteries in, and I hit go, and then it usually goes back to where it stopped. Sometimes with AI now, it'll actually skip that, go do a couple of swats, and then end up coming back to where it stopped. It knows that, oh, it says, oh, this is going to be more efficient on my battery to skip where I stopped and go do other things first. So they're really smart.
Uh, that being said, how many, I guess it would depend on how big of an area you're going with. But if somebody were to be playing, obviously they're going to drain batteries. How
Yep.
many would be a minimum number if they're going to get into spraying that you would think would be ideal?
It depends on the manufacturer, but like I tend to fly XAG. The other major brand is DJI. DJI has a single battery on the drone at any given time. I have two batteries with the XAG.
Okay.
So let's call it changes of batteries rather than single versus double. But you
Hmm.
want to have 3 to 4 sets or changes. That way, and you have a generator with a charger next to you because they can charge within 15-20 minutes with a fast charge. So that gives you time to rotate between batteries and just stay in full productivity at all times.
Perfect. Thank you.
Mike,
Uh,
Yeah.
Mike, the programming, would it be able to take into account wind speed and adjust its
It, it
size of the droplets?
It will not, it does not look at environmental conditions. It relies on the computer between your ears for that. What you can do is at the beginning of your flight, you can do an offset to prepare it for the day if you know there's a consistent wind coming from a particular direction. But it's up to you to decide if there's a change in conditions. You might change your droplet size in the middle of flight. You can do that manually. You can adjust your droplet size and flow rate independently in real time while it's flying. I've changed droplet size because I feel a gust of wind coming through, and I'll go up to a larger droplet for a minute or so, and then I'll go to a finer droplet. You can get to that resolution, but it doesn't know what's happening in the field at this time.
all right. Next question is from George. Jeff, maybe you want to answer this. I'm not sure. He's with your weather report, he says, is hay drying very poor currently?
Oh, uh, I would actually say, and there's of course a pro and con in this one. The forecast actually on the surface, I think, is pretty favorable if somebody was going to try to get some forage cured, and that warm temperatures, very strong drying rates during the day. That's good, but as so often happens with this challenge, management challenge in the occupation, we've got that threat of wetting from those showers. And so this one is, how lucky are you? You're feeling, I hate to say it that way, but it is risky. And I would say, again, based on the numbers that we have, most areas will remain dry. Now, that's today. You also have to look at that. There's a chance for more precip tomorrow as well. Same kind of deal. So are you going to be lucky 2 days in a row? And most areas, I think, will be in that category that they would be dry. And then we move into the weekend for most of the state, maybe the exception of the far north, where there'll be higher chances. We again, many areas are going to probably skip through the next several days without any precip. But there's something on what you need, of course, what the forage is going to be used for and the quality and so forth, things to think about. So it's tricky. This one's just a typical Michigan ag weather problem. But overall, that said, the conditions with a very warm forecast coming here are really pretty favorable. The drying rate should be pretty good.
Fantastic. Thank you. Mike, I am going to let you try to summarize all of your conversation going back and forth with Chris.
Fair.
You don't really have to. It's just an entomologist's curiosity.
Oh, I love it. Well, and this goes to what I was trying to get through with my slides is my goal was not to give a prescription, but to show you the variables. And I'm not saying you want to fly slow and you want to fly low to the ground and you want to fly with 50 gallons to the acre. What I want to say was you can adjust these variables based on what you need. And this is a perfect example of maybe you do want to fly really fast. Maybe you do want to fly high. Because if you're putting a granular product out there that you need to have land on the canopy or on the crop very lightly and with minimal bounce, you want to minimize that air effect of the drone. And so this is an example of maybe it would work. I haven't run across any examples of people talking about those products.
Yeah, I haven't either. Yeah,
Yeah,
so
that's an interesting.
I just wondered.
Yeah. But like for instance, in the fruit crops, we're dealing with a pollinator enhancer product. It's a pheromone. And most of the time we're talking about flying very slow to push droplets deep into the canopy. But for this pollinator product, all it has to do is get in the vicinity. And so we say just fly as fast as you can and just have it dribble right on the top of the canopy. We don't care about any of the rest of it. So what you're spraying and the weather conditions will completely change the settings on the drone. And you need to know what you're doing to know how to do that. And so that's a great example.
Yeah, this sounds like an art as well as a science.
Maybe, but I would say it's more, you have to know what's happening around you. The best pilots I know, they get out of their truck. They look around for a second. It's almost like you're in the movie Twisters with the tornado chaser guy. He's looking out here. He's looking. He's like, you know what? I think this is a 230 micron day. I think I'm going to have to fly just a little slower or whatever. They can feel it. They can sense it just from experience.
Thanks.
Fantastic. I don't know if we have anybody on here. Maybe Jeff. I don't know. What about the smoke effect on soil chemistry?
Yes, that would be a little out, but one comment on that. That is a possible consideration depending on what is burning. And again, it's all dependent upon where the smoke came from and what it originated from. But there are some circumstances in which some of that material is relatively more toxic potentially to vegetation, and then we have to worry that some of now the examples of this from the literature are coming from places like California, from Sonoma and Napa, where fires cause major problems with viticulture and with wine production, and the compounds from the smoke actually were deposited on grapes, etc. So that's sort of a specialized case, but it can happen. And here with the question regarding the soils, it's even more complex because there's another part removed spatially. But it is certainly theoretically possible. I have not seen personally anyone link that with some kind of and certainly I think the other question would be, is there any kind of a residual impact from this exposure? I haven't seen that, but it would be nice to get here a soil chemist to maybe would be more appropriate to comment on that. But I personally haven't seen a link.
I know Jeff's the more experienced person with something like this, but I'll throw in a little 2 cents as well. Being in the grape space, I hear a lot on the West Coast, say Washington, Oregon, California, with wildfires directly next to vines, next to crops, and causing smoke taint in the product, the wine, the juice, whatever. And even with that intensity and that, the fires right next to the vines, causing problems with the crop, I've never heard anyone really discuss the idea of soil chemistry effects from smoke nearby. Most of the conversation is direct effect after a fire's actually gone over that soil itself.
Fantastic. Mike, I didn't mean to exclude you. You're always welcome to jump in on any of these. I was just looking around saying who's on who might know the answer to this.
No worries.
Next question. How do drone spray compare with more traditional crop spraying airplanes?
If they are done correctly, they're very similar as far as quality goes. The difference is not so much picking one technology over another for quality. It's going to be based on productivity or fields that are specific to, that specific field. Larger fields, a fixed wing standard aircraft is going to be more productive. But what if you have power lines in the middle of the field, or what if you have a house or a neighborhood right next to the field? You might pick a different, you might pick a drone because it's lower drift than an aircraft. So the quality of the spray itself is not an issue. They're going to be same, assuming someone's flying the aircraft correctly. We've seen striping from aircraft as well. Same thing with drones. It's all everything else around the quality.
Yep. Is there a difference in patterns in a fully loaded drone versus an almost empty one because more downward air volumes are necessary to keep the drone airborne if fully loaded?
Yes. There you go. No. Now you do see something, you do see significant changes. When a drone is fully empty, you're probably looking at maybe 80 to 100 pounds, depending on the model. Fully loaded, you can be up of over 200 pounds. And each of those the propellers operate like the propeller on the front of an airplane. These are not helicopters. Helicopter, its rotor is a rotational wing. These are thrust propellers, so you're pushing air. And when the drone's half the weight, it's half the thrust. So you do see a change. And so you do see an in and outward effect of the swath over the course of the flight of the drone. And so that is getting really nice and high on your precision on how you're using the drone, and I appreciate it. But usually when we do testing on drones, we test at half full so that we can get an average. And I highly recommend, if you're doing some testing on your own, whether you're doing granular or liquid, you half fill your drone and you test it that way, and that way you get an average, and it'll adjust from there.
Very nice. Some compliments to you. Good job on the drone talk. We're going to keep it moving because I want to get through everything here. During the last couple days, the NOAA hourly forecast changed very abruptly early in the week. It showed very low to no chance of showers in the afternoon each day. Then yesterday morning, that changed. What caused the abrupt change, Jeff?
That's a great, very perceptive. I'm not sure, but that's a very, very good catch. It actually is some changes in the upper air that are slightly different, but enough. It had to do with this stability. Actually, some warmer air aloft that we thought earlier was going to be warmer than it is going to be less so. The other thing is there's more moisture. There's more of the raw material. So both of those things have contributed, but it's still a minor chance. But as we talked about with the hay drying, this chances are still there. But you're right. 2 days ago, there were virtually no mention. So it's a good catch. And it does this reminder that they're not big changes, but they're enough to maybe change our forecast sometimes.
Yep. There was a comment regarding soil effects. For what it's worth, they have burned brush piles on a field, and the section with the ash was actually their most productive. So that's very interesting. Now with that, we have a little bit of time left, not much. Do we have any specialists on who have some updates for us?
Hey, Jenna. So just a quick disease update. So we are getting pretty close to the end of that window for fungicide applications in soybean, if not beyond it in some areas already. So again, checking growth stages there is really important. You're welcome to call me in mid and late August and ask me about spraying white mold, but it's going to be too late by then. So just really, pay attention to that. So we want to go down the 4th node, look at the size of that pod. 3/16 of an inch is R3. Once it gets to 3/4 of an inch or about 2 centimeters, that's R4. And we just don't see any efficacy from fungicides at about that R4 growth stage. I've been looking at the risk maps to the disease forecasting tools. There's been like a little blip of risk increase with tar spot, and definitely a few more counties getting lit up. So I think the message there is just to get out and scout and be aware of what's going on. Oh, and the other thing, a little bit of southern rust being spotted in Indiana and other places. It does pop into Michigan from time to time. It's not very common, but just, again, be aware of what's going on in your crops. Thanks.
Thanks, Marty.
Ditto what Marty said about scouting.
Love it, Chris. All right. So that being said, we want to thank Mike and Jeff and all of our specialists who were on with us today as well to help give updates and answer questions. To all you attended, we appreciate it. That code was dropped one more time over in the chat, so I'm not going to end the meeting. That way, if you need that, you can get to it. But you're welcome to jump off. Thank you so much for joining us this morning. We really appreciate it.